what we'll be looking at today is to define machine learning, and then also to tell why use machine learning, and then we'll quickly look at the various types of machine learning, moving from supervised and supervised batch learning and online, and then also look at instant based as against the model based learning, um, as the types of machine learning systems. And then we will quickly also look at some challenges that come up with the design and then the creation of machine learning applications. And then finally, we also look at how to test and then validate machine learning systems, talking of issues of hyperparameter tuning and then model selection. My good friends, forget about these technologies. They are very simple concepts. Okay. Hyperparameter is simply about the very points within of the algorithm that you can change, so then it would improve the performance or the accuracy performance of your learning algorithm. Okay, that is simply what hyperparameterization is all about. So when we get to those tail end, I would spend huge time in explaining those concepts to you. All right, so this is exactly what we must discuss before the class gets to a close today. All right. So machine learning is the science and the art of programming computers so that they can learn from what? From data. So the given key away in here, the key takeaway in here is the data. There is supposed to be some learning to take place. The learning, the source of that learning is typically going to be on what? On data. So the volume of data, the quality of data that you would give to the learning algorithm will tell how much intelligence that algorithm is supposed to be, how good in its prediction it is going to be. Furthermore, we're going to look at two different sets of definitions. That is the very general definition, and we'll look at also the engineering-oriented definition of machine learning. Okay. In the general definition, machine learning is a field of study that gives computers the ability to learn. To learn in here is key, without being explicitly programmed. So in here we are going to learn, it suggests the development or the design and development of intelligent systems. So then, number one, they are able to learn. Human beings are able to learn. How do we learn? We learn from by formal and then informal methods. But typically learning means that there should be some set of examples. Okay, so if you're not learning from a book, then it means that by the things happening around you, those things become information that gets to your brain. So your brain gets to assimilate this information, does some processing on that. And by this processing, what are you doing? You are learning. Okay. So quite apart from this, human beings also do learn, but from what? But from books. When it comes to machines learning, how would they learn? The very source of information or data becomes the very source in which the machine would be what? Able to learn. Number two, the general definition specifies that specifies how the development is going to be done. We are going to do some programming, but it is not an explicit programming that we're going to do. That simply tells that we are not going to write the rules of the expected outcome, each line after the other. Okay, as compared to the traditional approach in development, where we write each single line of instruction telling how the output is supposed to be what? Achieved. In the case of machine learning, the learning algorithms are already in existence. Okay, we are not going to reprogram them. In instances where they may have to be reprogrammed, means that we want to add on to the current performance of what? Of the learning algorithm, but not necessarily to reprogram it, but to add some component to the existing algorithm, so then they will perform what? They'll perform better. So the key takeaway in here is that by machine learning, you are going to have computers that are able to what? Learn. They're able to learn because in this case, we are not going to explicitly program them, and furthermore, they are getting their information or their source of learning from what? From data, as it was specified in the earlier definition. Moving on, looking at the example of engineering the definition of machine learning, it mentions that a computer program is said to learn from experience represented by E with respect to task T and some performance measure P if the performance on T as measured by P improves with experience E. Now, what I will need you to quickly relate to is that E is what we are making reference to as what? The data. The data is the experience. How would it get experience? Human beings get our experiences from the people around us, the things around us, from books, the movies, the videos, the songs that we listen to. They all form part of our experiences. How we take decisions, why we made those decisions. How would the machine learn? The machine would learn from experiences. The experience is simply what is represented in the definition as what? E. But what we are saying in addition is that in practice, the E represents what? Data. Do you understand? Now, we will need to, anytime you are giving data to the learning algorithm, there is a task that is supposed to be accomplished. Like the example I said earlier on, if you want to predict the performance of a student, I said that you may have to give the to the learning algorithm information about the student in his or her first year, second year, third year, and then that will help that the learning algorithm can base on the historical data of the student to predict what the next performance of the student will be when he or she is in what? In the final year. How is the machine able to do this prediction? It is able to do this prediction from what? From the historical data of what? Of the student. Okay, that is the base. So the tax, for example, T can represent the student what? The student performance. Wanting to predict the student performance. Or in the example also of the spam filter, the E could represent a data set of what? A data set that contains a spam and then a harm. Okay, so when the learning algorithm is introduced to the rows that are within of the data set, a row can be a representation of a spam or a harm, a spam or not a spam. So each row, the set of rows introduced to the learning algorithm would help the learning algorithm to learn about the attributes of a mail that will make it malicious or not malicious. Do you understand? So maybe most of the time, malicious mails may come with some range of IP address, or it may come with some specific hashtags, or it may come with some set of words. Okay, so when this data is given to the learning algorithm, it can learn from the given words or the hashtags or the range of IP addresses to decipher, to understand that by these incoming network data, this is a spam or not a spam. So in that case, that data would represent what? The E. The T would represent what? The filtering in which the spam filter is supposed to what? Do. So quite apart from the example of predicting student performance, we can represent the task to be done, okay, which also would also need student data, okay. The T in this case also can be a representation of the task of of classifying mail as either a spam or what, or a harm. Now, quickly moving on to finish the explanation on this, I have explained to you T. Anytime the task is created, a model is created, we will need to have some matrices that we will use to measure the performance of what? The learning algorithm. A typical example in the case of the spam filter is to have, let's say, the ratio of the identified spam, correctly identified spam, the ratio of that as against what? The harm. How many spam were identified? How many harm were identified? Maybe this is what we want to use to measure the performance of what? Of the learning algorithm. So you take in total, maybe 100 messages came in. How many of them was the machine able to correctly identify as a spam? How many out of the 100 was the machine able to correctly identify as what? As harm. If this is the matrices that you want to use to measure the performance of the learning algorithm, then that is what you are calling what? P. Quite apart from this, we can also use what we call accuracy to measure the performance of what? Of the learning algorithm. How many of these instances of incoming mail were correctly identified as a spam or harm? Or in the other example of the student performance, how many of these given students was the learning algorithm accurately able to predict their performances? Okay, then that is what we are making reference to as what? As P. So going over again, we will say that a program is said to able to what? Learn from given experience E with respect to some task T and some performance measure P if the performance on T as measured by P improves with experience what? E. So as much as we are giving E, which is data to the learning algorithm, its experience should what? Should improve. Okay. So practically, this is what machine learning is all about. Creating a hardware or a software to be able to learn from what? From a given data to achieve a specific task. At this point, any questions, please? At this point, please, any questions? Abbas Adama, do you have any question? Abbas Adama, do you have any question? All right, so Freeman, I should come again on what, please? I should come again on what? Yes. So can you ask a question to clear your confusion? Isaac, where lies the confusion? All right, so I will repeat myself on this. Machine learning, we should have a learning algorithm which is pre-programmed for you. So in this case, it will come in the form of what? A library. Now, this library, what it is going to help you do is that when it is giving data, okay, in the situation of accomplishing or predicting a student performance, you must give it data that is historical data of what? Student records in terms of their performance. It should be given to the learning algorithm, and then it will learn from that data. When it is given a new data to suggest that this student would have this performance. Quite apart from this, when you look at the area of e-commerce, when you visit, let's say, YouTube, based on the kind of videos that you watch, the learning algorithm of YouTube will create a profile for you. So what is actually this profile we're talking of? The profile is actually to learn about what you like the videos that you like and then dislike, and then it will take more interest in the videos that you like. So then it will find more other videos that looks like what you watched earlier on. But in this case, you have not watched these ones yet. Those ones you have not yet watched, but they look almost like what you watched earlier on. That is what it would want to suggest to you. So let's say if you went to YouTube and then you check on wedding rings, or you check on flowers, okay, then YouTube's learning algorithm will create a profile for you, which includes the kind of videos that you watch. In this example, it will be that you like what flowers. So it will look at other videos on YouTube that do share ideas on flowers, and then it will suggest that to you as a video you must do what? You must watch. How was this done? How did YouTube get to do this? YouTube get to do this because of the learning algorithm, and that is a practical example of what? Machine learning. Okay, so we simply looking at this definition to help us appreciate or understand what machine learning is. Isando, this is what I was making reference to the other time, that we would have to allow one person to finish talking, and then if you want to ask a question, you can either raise your hand or you write it in the chat panel. When I'm talking and you also want to talk at the same time.
Hello.
Anyway, go ahead and ask your question if you have one. Isando, do you have your question? Or by mistake you turn on your microphone? It's too bad.
No, this is Eric. Eric, let me see.
Yes, go ahead and ask the question, please. Am I moving very fast? Oh, I didn't know. I have been on this live for almost 30 minutes. All right, so I'll still hold on to the question. Isando, Emisa, I thought you wanted to ask a question. All right, no problem. When you are ready, you can go ahead and ask the question. So we'll move on from here. So the spam filter.
Sorry for cutting. Anyway, it's because of my network. That's why I
machine learning program. Its basic functionality is to flag out
the spam. It's Eric. Emisa is not Isando anyway.
And
also it's Eric,
on
please,
regular meals, and then that which are harm.
Yes, my question is, so the machine will only learn when it is being fed with data.
Isando, what do you want to do?
No, I wanted to ask a question.
Yes, you must allow that you are given a chance to ask a question. I held on for almost a minute. You are not talking. And then you just showed up and you begin to talk again. This becomes a distraction. Can we do this? Please, if you want to ask a question, there is a button to help you raise your hand. I would see it. I would pause the presentation, and then I'll give you a chance to ask a question. Otherwise, you would see that the two of us will be talking at the same time. Emisa Isando, you have the chance to ask the question. You can go ahead, please.
But please, I say my network is not allowing.
Yes, I hope by this you would appreciate
so
why.
Please continue. I will write it.
Okay, sir, that is okay. All right, so let's continue. So what we're looking at further is that we have a concept in here called training set. Training set. The training set. The training set is more often derived from the total data sets that you have, your full data set. A percentage of it you want to use to train the learning algorithm. You want to give to the learning algorithm as what you are calling E, the examples, right? So you take an example that when you have an Excel sheet. The Excel sheet contains, let's say, in your class, if you have, let's say, 45 students, then for that particular single course you are teaching, each of them have, let's say, scores for their class test, mid-semester, or midterm, assignment, and then final exam in it. So you have that for, let's say, 30 students. Okay, out of this 30 records that you have in your Excel sheet for your class, you want to use, let's say, 25 of those records to create your model. These 25 records from your data that you have about your student is what we are making reference to as what? The training set. Do you understand? Why? Because that is what you are going to give to your learning algorithm as example. The example data it should look at. So then, when it is given a different or a new data, which was not in the earlier 25 records in your student data, it can also base on that to do what? To do a prediction. Okay, so I will repeat myself on this. You have 30 students. You have, let's say, 30 students in your class. Out of the 30 students, you want to use 25 of them, 25 of those student records you have recorded in your Excel sheet to train a learning algorithm. What is the essence of this? So let me help you get that a mental picture of it. So you have your data here. You are going to give the data to the machine learning algorithm. Okay, I hope you're able to follow. Okay, you are going to pass on your data to your machine learning algorithm. Now, what we are saying is that in our case, for example, the data represent student data. Okay, so I will just use ST to represent student data. Now, this student data contains actually information about the performance of your student in just one of the courses that you are teaching. And then we are adding on that in total, let's say you have 80 students in your class. If you have 80 students in your class, then you may want to use, let's say out of the 80, you want to use 60 of those records in the data as examples. You want to give 60 of those records as examples to what? To the learning algorithm. So all the time it will look at, let's say record 1, the student had 3 for classes, and then had 2. Okay, the student in the first example, the student had 3 for class tests, had 4 for, let's say, assignment, had 20 for midterm, and then had 70 for final exam. In the next one, the student had let's say 5 for class test, and then had 7 for assignment, and then had 15 for midterm, and then had, let's say, 65 for final exam. In the case of the first student, he had A. In the case of the second student, he had, let's say, A minus. So you have, let's say, sample of these records, 80 records of these. Now, what we're simply saying is that the learning algorithm will learn the first example. When the student had 3, 4, 20, and then 70, the student had A. When the second student had 5, 7, 15, and then 60, the student had what? A minus. So you have several other records. The learning algorithm will learn all the pattern. Will learn all the pattern in what? In the given data. So then, when it is given another data that was not part of the 60 records that were earlier on used, it can still predict. Now, the fact we want to explain here is that the 60 records you have used to train the learning algorithm. So then we have a model that can do prediction, or we have the predicting model that predict. We had a predicting model by passing on these 60 records. It is these 60 records we are calling what? Training set. Training set. Okay, so this is it. Training set. Out of the 60 examples we have in your student performance data, it is 60 of those records we use to train the learning algorithm. And then we are going to use the rest of it, which will be what? The 20 remaining records to test it. Okay, so number one, we pass on data to the learning algorithm. Out of the 80 records we have, what we are passing on is what? Is the 60. The 60 is what we call what? The training set. Any questions on this? First, someone will ask a question. So let me see. No, let me start with Joseph. Through the data given in the learning algorithm of Facebook, it is able to suggest for new friends. My understanding. Yes, you are right, Joseph. That's correct. First is also asking the question. I think when it comes to Facebook, it uses your location, place you have checked in before, institutions, and sometimes your hometown to suggest friends for you. So in this case, the data you gave about yourself is what the machine learning algorithm uses. Yes, that is correct. So is the training set same as sampling? The training set is not necessarily the same as sampling, but you sample a part of your total data set to be given to the learning algorithm, and then we call that training set. The reason why I'm saying that sampling is not necessarily the training set is because apart from the training set, we also have what we call the validation set, and then we also have the testing set. And in all of these, we did what? Sample a part of the data. Okay, so let me be much faster on this. The training set technically all the time we use 80% of the total number of records in the data set for training, and then we use the remaining 20% for testing of the learning algorithm. All right, so there must be data. You pass on the data to the machine learning algorithm, and then the output will have it what? The predicting model. The predicting model must be evaluated. Okay, so after you have the model, you must evaluate the model. How do you evaluate the model? That is where we talk of what? We talk of the P. P is the representation of the evaluation matrices, which can be the accuracy, or in the case of the example of the spam filter, we're talking of the ratio of the spam as against what? The harm. So how many out of the total records of incoming messages were identified as a spam, how many were identified as what? As a harm. All right. Okay, so that is it about training set. At this point, please, any questions? If you didn't get it, in simple essence, the training set is the percentage of the total machine learning a percentage of the total data set you are given to the learning algorithm to train it. Okay, so to train it, in training it, we have what? The model. We do testing after we have the model. So the 20% of it is now tested on what? The model we have created. You want to see how it will now what? Perform. All right, so quickly, let's move on. So like I mentioned earlier on, in relation to E, P, and the like, we would have to measure the performance of what? Of the learning algorithm based on matrices, for example, as accuracy, in terms of how accurately it was able to classify an incoming data. All right, so now, whilst we understand what machine learning is, we will want to now understand why we want to use what? Why we want to use machine learning. Now, to understand why we want to use machine learning, we want to look at a situation to consider how you would write, for example, a spam filter if you are using what? The traditional programming technique. The first thing you would do, number one, you would look at what spam typically looks like. Okay, spam simply is made up of some words or phrases. For example, for you, credit card, free, and then let's say it may contain the word Amazon. So quickly bringing you to speed. To identify a spam or a harm, it is dependent on what? Some set of what? Words. So based on these set of words, we will classify a mail as what? A spam or a harm. Okay, right? So perhaps you would also notice that few other patterns in sender's name and then email body and then so on. These are all other attributes that you can use to identify what? A spam. Number two, you would also write a detection algorithm for each pattern that you noticed. Okay, maybe the pattern in the words that are used, the pattern in the sender's name, the pattern in the email body, and then some other attributes that you may want to what? Consider. And then you would use that to flag emails as what? As spam, if those patterns are also what? Detected. Now look at all of these number of words, and then you want to write a rule for each one of them. Then the third step you would look at is to test your program, and then repeat the step one, which is looking at the words again, and then you repeat the step two also until you are sure your algorithm is able to what? Learn correctly. In this case, we were looking at typically the traditional approach. Okay, so this is it. This diagram in here, the flow charts in here, is a representation of the example I was looking at. So you would have to study the problem. So in here, studying the problem for a spam filter is identifying simply what? The words of phrases. So for example, for you, credit card, identifying the sender's name and then all the pattern and all of that. And then you have to write rules for each one of them. You must evaluate the rule. If the rule, you evaluate your algorithm and then you think it is okay, then quickly you launch it. If it is not okay, then you would have to analyze where the errors are coming up from again. And then you study the problem, you write the rules, update it, evaluate if it is okay, you move on. If it is not okay, then you come back again through this cycle until you are 100% sure the traditional algorithm you have written is what? It's perfect. So you can see that all the time you may have to be what? Writing rules. Okay, now look at the machine learning approach. The machine learning approach, you study the problem. So how do you study the problem? You pick a learning algorithm. Are you following? You pick a learning algorithm, you give it data. What does the data contain? That is the question you want to ask. This is the question mark. What is the content of this data? This data contains what? Contains examples examples of records showing what a spam is, and then also what a harm. So it is showing these two. Okay, so you pass that data on to the to train the learning algorithm. If the algorithm performs well upon the matrices of the evaluating the algorithm, if performing well, then quickly you do what? You launch it. If it is not doing well, you analyze the errors and then you study the problem again. In this case, look at this clearly. How different is this approach from the traditional one? You can see over here, the only thing we are introducing all the time is what? Is data. The only thing we are introducing all the time is data. We didn't write any instruction in the machine learning approach, but we wrote in rules or instructions all the time when the situation was what? Was changing. So the machine learning approach makes it much easier, much simple. Why? The question, why? Because we are not writing rules, but we are instead all the time focusing on what? The data. The more the data, it means that the more examples you have given to what? To the learning algorithm. The more examples you give to the learning algorithm, the more intelligent or the more accurate a model is able to what? Is able to do a prediction. All right, so one of you is asking the question, Isandro Emisa, the machine learns with the data it comes in contact with, right? Yes, that's correct. Which other question is here? So far, using part of the total as TS. The remaining will be used to test if I'm right. Yes, that is correct. Not all the time the remaining used for testing. By common practice, 80% is used for training, 20% is used for testing. In some other cases, there is a third part. So then you could use 60% for training, 20% for validation test, and then you could use the rest, which is also 20% for testing. Okay, so the validation test is simply to validate what was done at the training level, and then to make sure that the error margin of the prediction is fairly reduced before what? The testing is done. Okay, so it is not all the time that the total data set is divided into two components, that you have 20% for testing and then 80% for what? For training. In some other instances, you could have 60% for training, 20% for validation, and then testing respectively. All right, so moving on, still trying to answer the question, why use machine learning? So you could realizing that if the spammers notice all that their mails are containing for you are blocked, if they are blocked, if they notice that all of the spam mails that they are sending containing for you are blocked, then they may now change, instead of using the digit for and then you, they will now change to what? Using letters for you, right? A spam filter using traditional programming technique would need to be updated to flag what? The for you emails. If spammers keep working around your spam filter, you would need to keep writing what? Keep writing new rules, okay? But if you consider the situation of using machine learning, okay, the focus is data. You give the data to the learning algorithm to train it, you evaluate it. If it is doing well, you launch it, okay? If anything is changing, you have an update on what? On the data. You update the data, you pass on that data to what? To the training algorithm. Now tell me, at this side, why are we writing rules? We are not writing rules because our focus is not to write rules. The learning algorithm does not learn based on rules we write. It learns based on what? Give me an answer. Give me an answer in the chat panel. Let me see if you're able to follow. The learning algorithm learns based on what? Not rules, but based on what? Exactly. Prosper, your answer is right. Eben, your answer is right. It is typically based on what? The data. So the more the volume, the greater the volume of data that you are given to the learning algorithm, the more it is able to what? Able to perform. Okay, the more its accuracy increases. So another area where machine learning science is for problems that either are too complex for traditional approaches. For example, it's in speech recognition. How I will pronounce my T will be different from how you will pronounce your T, even based on which region either of us are coming from. Okay, there are different pitch and then intonation issues. So it is very difficult and then very challenging to come up with a traditional algorithm that states every rule one after the other. Look at even the set of human languages that we have. How can you write rules, instructions? So then for only Hausa, all the variants of Hausa, it can identify all of the words and then appropriately capture them. When you come to English, there are different intonation in English. Even among the British, there are variants of what? Of their intonation. So it is very difficult in those cases to be able to do to use the traditional approach in what? In writing algorithms to capture a speech. Okay. So in this case, it will be very good that you instead capture what? Examples of voices. Capture examples of human voices and then give that to a learning algorithm. And then when it gives more examples of human voices to the learning algorithm on its own without rules, the learning algorithm can learn to identify what? Or recognize human speeches. Also, one typical area in which you would want to use machine learning is for the reason that machine learning algorithms can help what? Human beings to what? To learn. Because these machine learning algorithms, they are able to learn deep down into what? Into data. So then some patterns that human brains are unable to discover, these learning algorithms are able to discover those patterns within of those voluminous data and then complex set of what? Data given it to be able to understand. Okay. And when that is done, we are able to go back to that data to inspect the solution in which the machine learning algorithm proposed, to look at how was it able to learn to identify a spam from a harm. And then we will look at that approach also as human beings to adapt that approach and then use subsequently. Okay, if we were unable to learn to do weather forecasting as humans, we want to look at how the machine learning algorithm was able to what? Able to do weather forecasting based on these voluminous data. So you can think of the time in which weather forecasting started. Even if it started in let's say 2000, the year 2000, from the year 2000 to till date 2021, that is what, 11 years. Look at capturing data morning, afternoon, evening, night, every day through till now. How much of records of data that you would have, and then all of this must be computed on by a human being to tell how the weather will be tomorrow. How accurate would this be? That would be so cumbersome in scenarios like this. It is very good that machine learning algorithms are used. Now, when this is done, a human being can come and then do an inspection of how the machine learning got that solution, inspect the solution to understand how it did it. And then by that, you can adapt that approach as a human being to also what? Solve those same problems. Now, the capability of the machine learning algorithm to learn to discover various patterns within of a huge data given it is what we call what? Data mining. Okay, at this point, My good friends, any questions? Any questions at this point? Emmanuel Dua, Owusu, do you have any question? Evans Minsa?
No, sir. No, sir. No question.
All right, so quickly we move on from here. Right, so in summary of what we have said earlier on, all we have said was that problems for which existing solutions require a lot of hand tuning or long list of rules. Machine learning algorithms are much relevant to be applied in those cases because they will definitely perform better, right? Number two, complex problems for which there is no good solution at all using traditional approach, then the best machine learning techniques can find what? Can find a solution. So in those cases, machine learning algorithms becomes that much what? Relevant for use. Also in situations where we have fluctuating environment. You take the situation of weather forecasting. Earlier on, we used to have a lot of rains in November, December, but the patterns have changed. Did we experience Hamatan last year? In our region, I am in Accra. We did not experience the Hamatan. So when is it going to come? So if you are basing on just few data to do predictions, it will become the failure of the prediction will be what? Very high. So simply put, in the area of weather forecasting, it fluctuates a lot. There's a lot of fluctuation in the records of values. The pattern is not the same every year. The atmospheric issues keep changing all the time. In those fluctuating environments, machine learning, deep learning is the best of techniques and the methods that need to be what? Needs to be deployed. Okay. Finally, getting insight about complex problems. Like I said earlier on, human beings cannot be able to decipher patterns or uncover patterns from complex data. You can allow the machine learning algorithm to give the solution, and then you open up the solution to see how did they solve the problem, and then you learn how the machine learning algorithm solve the problem, and then you adapt the solution that is used to solve the problem as the human problem, the human solution to use subsequently in solving what? Similar problems. So this answers why you would want to what? Use machine learning. Now, quickly, we want to also further look at the different types of machine learning algorithms. Okay, there are several wonderful types of machine learning algorithms that we can use, and they are put on categories based on, number one, whether or not they are trained with human supervision, or whether or not they can learn incrementally or on the fly, or whether or not they work by simply comparing new data points to what? Instead, comparing new data points to known data points, or instead detect patterns in the training data and then build a predictive model. So these are the three major categories or categories of reasons for which the types of machine learning algorithms we are going to discuss are what? Are categorized. Okay, so number one, the very popular type frequently used is called supervised learning. Now, in the supervised learning, the training data you feed to the algorithm includes what? Includes the desired solution. Never forget this one. What you use to identify or to understand whether what you are supposed to do, you should use supervised learning or not. If you look at the data you are going to use to run your experiment or to create your model, if number one, they are labeled or it contains the output field, then it is supposed to be what? A supervised learning. Okay. So in typical situations, like the example I used earlier, where is this? I hope I kept that example. Good. So in this example, where we're looking at, let's say, predicting the performance of a student. So the data has these as input: class test, assignment, midterm score, and final exam score. And then it also includes what? The grade. The grade is what we are calling what? The output. Okay? The grade is what we are calling the output. and then it is also in the data set, which and then it also includes the input fields, which are let's say assignment, classes, midterm, and then what, final exam. These are what we use to predict what, the grade. So the input fields and then the output field, when they are both together in what, in the data set, when they are both together in the data set, we use what, we use the supervised learning. I hope you understand this. If you do not, please let me know if you have a question. So when supervised learning, it depends directly on the kind of what data you have. If the data has the input field plus the output field, then you can do what, supervised learning. Okay, so a typical example is still, for example, the spam filter. Look at this. So this is the example message. This is another example message. It is being given a label that this is what, a harm, which means that it is not a malicious mail. This is another example message, which we call instance. This is also what, having its label that it is what, it is not a spam, so it is a harm. This is another instance of a message, but this is what, a spam, right? And then this is another message in the training data set. It tells that this is also what, a spam. Another message here, this is a spam. Another message here, this is what, a harm. So this is the training data set that we are going to use to what, train the model. Now, when you give this as the training set to the model, to the learning algorithm, to the machine learning algorithm, we now have what, the model. So now you introduce a new instance to the model, sorry. Now, what is going to happen is the model is supposed to look at this new message. Are you following? It should look at this new message and then tell us, what is this? Is this a harm or a spam? Do you understand? How would it know? It would have stated from the training data set that when it had this example message, it was what? Not a harm. This is not a harm, but this is a spam. This is a spam, this is a spam, this is what? A harm. So it is going to be based on the examples you have used to train it to look at the attribute of this new message to tell us this will be a spam or not a harm. Okay. So in the case where the data set is labeled, the input set is labeled, and then we also have the output set labeled. What we do is what? Supervised learning. Examples of machine learning algorithms that help us do supervised learning is known as, for example, you have the KNN, or the K nearest neighbor, and then we also have the linear regression, logistic regression, support vector machines, decision trees, and random forest. And then we also have what? Neural networks. All of these ones are examples of learning algorithms we can use for supervised learning. Now, the very opposite of supervised learning is what we call what? Unsupervised learning. So in the unsupervised learning, the training data is what? Not labeled. Okay, so you can see over here that the training set is what? Not labeled. Now let's look at instances in which let's quickly look at some examples of learning algorithms that are used for unsupervised learning. We have that for clustering. For example, the K means the DB scan. We have the hierarchical scan analysis, which is simply put ACA. And then we have also some other forms that are meant for anomaly detection and then novelty detection, which is the one class SVM. And then we also have the isolation forest, visualization and dimensionality reduction. Also, under that, we have the PCA, we have the LLE, and then we have the TSNE. And then we have also that which is used to measure association rule. All of these ones are unsupervised learning algorithms. All right. So repeating myself, the unsupervised learning algorithms is still dependent on what? On the data. This time around, the data is not labeled like we saw in the earlier example. When it is labeled, so then you can see the input from the input and then the output. Then we use what? Supervised learning. So a typical example of an unsupervised learning scenario would be that you have a block, okay? When you have a log of block to your visitors, you want to do analysis of the log, people who have signed in and out of your social media block, okay, to understand the various kind of visitors that you have to your blog. Maybe some of them, they come, majority of them are writing comments, or and then some also come and then they only view, let's say, pictures. Some also come, they view only videos. But this set of group, maybe it is an intersection of these three. They view the videos, they also watch the pictures, and then they also write what comment, which means that the log of data is typically what not labeled. In this case, you didn't do the classification, but you want to allow the learning algorithm on its own to do this classification of users who visited what your blog. How did it do that? It is simply by passing on the data which is not labeled to the learning algorithm, and then on its own it should be able to tell the different kinds of group of people who use what your block, and then the intention for the use of that particular block. We can also use the TSNE, which is stochastic neighborhood embedding, which is also an example of an unsupervised learning algorithm to present a pictorial view of what an unsupervised learning. So on its own, by the identification rule in here, the plus using the red symbol represents cats, moving from that to automobile, truck, frog, down to what? To deer. You can see by this color pattern, it can tell you that at this section, we have this set of what? This cluster of what? Automobile. At this side, we have truck, we have birds in this group, we have cats in this group, we have dog in this group. All is done based on what? These color indentations, that is what is given to it. In typical situations like this, it was done without a labeled data. We do what? Unsupervised learning. Okay? Unsupervised learning, one of the very good uses of unsupervised learning is to do what? Dimensionality reduction. Now, the very essence of dimensionality reduction is to simplify data without losing too much of what? Information. Okay? So we take, for example, a car's mileage may be very correlated with its age. So the dimensionality reduction algorithm will merge them into one feature that represents the car's what? Wear and tear. Okay? So the wear and tear will become a better feature, a better attribute about the car you want to give to the learning algorithm to predict, let's say, the price of the car instead than just passing on what? Passing on the age and then the mileage. But if it is able to predict, if you give it a feature as the car's wear and tear, that is a very important feature about the car that can be used to what? Predict how much the car would have to be sold. In that case, of doing dimensionality reduction, it is very important that we use what? We use an unsupervised learning algorithm. Also, in anomaly detection, we can also do what? Use unsupervised learning. So the data will not be labeled. You want to let the algorithm to tell whether the data is an anomaly or it is what? It is normal. Those of you who may be interested in doing research work using machine learning, but for security, you want to use machine learning algorithm to analyze data on a network to tell whether there's a possible intrusion or there is no what? Intrusion. We tell, for example, how would you determine on a network if it is a fraudster that will want to use someone's credit card information to do purchasing online or to withdraw from someone's account. You can do some of these tasks all using what? Machine learning. And they typically fall under what? Unsupervised learning. They can also be supervised. That is, if the data is what? Is labeled. Now, also another area in which we deploy unsupervised learning is in association rule. I know majority of you have seen this before, but you didn't know this is what it was called. You take, for example, when you go online, it's and then e-commerce site, you may see a portion that will say that, let's say, all those who bought external hard disks also bought, let's say, flash drives. Have you seen that before? Or all those who bought laptops also bought, let's say, digital camera. How did it learn to do this? It uses what we call association rule. The association rule is a typical example of what? A machine learning technique that is used to create correlation between a user and what? And then a purchase set of items. So then to find more people who look like you in terms of what? Purchasing. More of the people who are buying laptops are buying digital camera. So if you have also bought a laptop, then you look like one of those people who bought what? A laptop earlier on. So it will suggest to you that because all those who have been buying laptops have been buying what? Have been buying digital camera, then it will recommend to you that you should also buy what? Buy let's say a digital camera. Okay, that is what we call an association rule, and it is an application of unsupervised learning. Now, moving away from supervised and then unsupervised learning, we also have what? Semi-supervised learning. Now, before we discuss semi-supervised learning, let's do a quick recap. When? Give me responses in the chat panel. When do we do supervised learning? In what instance do we do supervised learning? Yes, your responses. You can talk if you want to. In which instances do we do supervised learning? James Owusu. James, you have logged in and you are sleeping, isn't it? Bernard Lalovi. Okay. So Emmanuel, your answer is correct. When the data sets are labeled, then we do what? Supervised learning. Right? So when the data is not labeled, that is when we do what? Unsupervised learning. In the case of what we are looking at currently, semi-supervised learning is done when we have partially labeled, when we have partially labeled data. That means that part of the data is labeled, some other part of the data is what? Not labeled. A typical example of that is seen in photo hosting services, such as on Google Photos. Okay, once you upload all your family photos to the service, it automatically recognizes that the same person, let's say A, shows up in photo 1, 5, and then 11, while the other person B shows up in photos, let's say 2, 5, and then what? 7. Okay, what you may have to simply do is to identify one of the people in the images, and then subsequently any other image that you upload, it can quickly identify that. Facebook has this same attribute. When you tag one person in your post, another time you upload an image on Facebook, because it has learned from the earlier tag that you did, automatically it is able to face recognize that individual within the picture. If the image is that much clear, it's able to identify it. So then you will not have to tag the person directly. And then those that have not yet been tagged in any of your images, it will suggest some possible friends in your friend list that you may want to tag them. Okay, so we use semi-supervised learning in achieving some of these fundamental texts. So most of the time, semi-supervised learning algorithms it's a combination of the unsupervised and then supervised algorithms. Okay, a typical example is what we call the deep belief network, which are based on unsupervised components called the restricted Boltzmann machines stacked on top of what? One another. What are these restricted Boltzmann machines? They are all machine learning techniques that are used in extracting patterns from a given data. Okay, they are trained sequentially in an unsupervised manner, and then the whole system is fine-tuned using what? A supervised learning algorithm. What I will need you to understand here is that fundamentally, whether the project you're going to do is unsupervised or semi-supervised, it will get to a point where the data must definitely have its output column labeled before the prediction will begin. So all the learning processes all the time ends with the supervised learning before the model is created. Okay. And then another wonderful side in machine learning, which is more intriguing, is the unsupervised learning. A typical example of the unsupervised learning is the reinforcement learning. You look at this image that we have here. You want to create a robot, and then the robot must learn to move. Now, in the movement of the robot has within of it what we call the agent. The agent should learn from its environment, and then study its environment to determine the available variables, and then use these available variables as number one to provide a reward or a punishment as the basis of of the learning. Okay, so look at this. If the robot moves towards the fire, the agent is supposed to use its rule base to to punish or to deduct marks by the deduction of points from the rule base. The robot tend to understand that moving towards fire is wrong. So it will now try to move towards the right. As it moves towards the right, there is a plus. Okay, when it moves towards the left, there was a reduction of, let's say, 50 points. If it moves towards the right, there is an addition of 50 points. So it tends to understand that moving towards the left, which is pointing to fire, is is bad. Moving towards the right is is good. How did it learn to do this? It uses the process called reinforcement learning. Okay, which use an agent in this context to observe their environment, and then it selects the action, and then it gets reward or it get punishment in return. Okay, so most of the time in robotics, this is what we use. That good friend who said that he want to, at the end of this class, create the driverless vehicle, right? More of the application of that is to rely on reinforcement learning in creating those models. All right. So our discussion, what we have looked at so far, is to have discussed what machine learning is, why use machine learning, and then we have also looked at some types of machine learning, discussing supervised learning and then unsupervised learning. At this point, please, any questions? Please, any questions? You said SL. SL is what? Supervised learning, you mean? Needs something like features to predict. And unsupervised learning is opposite. So machine learning prediction price of a car based on its features, I thought would be supervised learning. Yes, it can be supervised learning or unsupervised learning. It is all based on the given data. If the given data has the label in it, then it becomes supervised. If it doesn't have the label, then it becomes what? Unsupervised. So it is all come back to the nature of data. Okay, so Joseph is saying that he understands what the training set is, but not clear on what the model is. All right, so I think on one of the slides, I was trying to help you to get the clear distinction between the training set. Okay, so a portion, this is your total data, right? It contains 80 records, and then you are using 60 of those records to train the machine learning algorithm. That 60 records out of 80 you are using is the training set. Okay, I am glad that one you understand. What you want to find out is what is the model. Now, whenever you train the machine learning algorithm using the data, you have a model. Do you understand? The model is the output, of applying the data to the training data to the machine learning algorithm. Okay, or training the learning algorithm with data, it creates a model. Okay, the model is what you want to use for the prediction. In our next meeting, we have the chance to start the protocol. You would see this more clearly, so then the confusion is cleared out. But the model is simply the output from training a machine learning algorithm. Please, any other questions? No, we do not have only two types of machine learning algorithms. But what I've discussed for today's class is only the supervised, unsupervised, and then it's semi-supervised. What we are left to discuss is the batch and an online, instant-based, and then model-based machine learning algorithms. We will do that in our next meeting.